Hi guys, welcome to another physics video. In this video, we're going to see how to transform a vector that is in the regular form to polar form. And this is the example that we have. The rectangular x component is 10 meters per second. And the rectangular y component, or the rectangular coordinate in y, equals minus 7 meters per second. So the things that we are going to find is the drawing, the quadrant, the magnitude of the vector, and the angle. Okay, so let's begin. I recommend you to have at hand your calculator because we are going to use it. Okay, so the first thing that I'm going to do is that I'm going to draw the vector. Okay, so this is the Cartesian plane. Remember that it's not necessary that you fill every time that you perform the drawing with all the information. I just do it because, this is, you are learning this stuff. So the first time that you do it, this is very important. So 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay, so, let's see. Now, also the quadrants. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So, in order to begin with this problem, you might ask yourself, in which quadrant do we have positive x and negative y? Got it? I repeat, positive x and negative y. Well, that should be in the fourth quadrant because in that quadrant, x goes to the right and y goes down. So the quadrant that we are going to work with is the quadrant number 4. So, okay. So next thing, let's draw the components. Remember that the components are drawn from the origin of the Cartesian plane. So bx goes to the right. This is bx. And by goes down because by is negative. This is by. Okay, so now we're going to find I'm going to draw the vector. Now the only thing that I know is that the vector is between these two rectangular components, or is between 0 degrees or 360 degrees and 270 degrees. So as I said before, it's not necessary that you do it with accurate. So I just want to represent the vector. So this is the vector over here. This is the velocity vector. And the angle that I need to find goes from 0 degrees. Always from 0 degrees until that angle touches the vector. And this is the angle that I need to find. Okay. And so far I got the drawing, check mark, and the quadrant, check mark. Now next, what I'm going to do, I'm going to draw the little triangle. Remember that every vector forms a right triangle with its component. So I'm going to draw the triangle. Over here, I got the hypotenuse. I guess I told you in the previous video that the vector is always the hypotenuse of a right triangle. Okay, this is the b vector. This is the x component, bx, and this is by. Oh, again, that's by, bx, and by. Okay. So the first thing that I'm going to find is the magnitude of the vector. And I don't know if I just gave you the formula in order to find it. So if you see, this is a right triangle. So we can use Pythagoras in order to find the value of the hypotenuse. So the magnitude of the vector equals the square root of bx, the vector bx raised to the square, plus the vector by raised to the square. Okay, I don't know if I already gave you this formula, but if that's the case, well, this is the third formula that we are going to work with. This is the third formula. And I recommend you to circle it because that's a formula that we are going to use a lot during the course or during this playlist. Okay, so well, let's find the magnitude. Well, if I substitute, that will be uh, the magnitude of the vector equals the x component, that is 10 meters per second. I'm just gonna write the numbers: 10 plus minus 7 square. And I recommend you to have your calculator at hand. I have this calculator with me, and so I can show you. So the thing that I'm going to do is that I'm going to use this button, the square root. So 10 square plus parentheses minus 7 square, and then I hit the equal button. So it's the square root of 149. So that means that that number is not an exact number, it's not a whole number. So with this button over here, S and D, I press it and it gives me the decimal number, and it's going to have infinite decimal of numbers. So let's write it. The magnitude equals 12. The magnitude equals 12.2065. 2065 meters per second. Okay, that's the number. I hope you got your calculator at hand, and if it's a calculator like this, well, you will not have any problems. Okay, remember that this is the magnitude. This is only the magnitude. So if I'm writing the magnitude, that means that it's not a vector. Remember that in order to be a vector, well, I need the direction. And one important thing, the hypotenuse or the magnitude of the vector, that vector cannot be negative. So I'm gonna write it here so you can have in your notes. It's always positive, because comes from a square root, so the number inside of the square root cannot be negative. Okay, what about the angle? Okay, so let's find the angle. If you see, I got this angle over here, and this angle that is here is this little angle. Okay, but you need to understand that this is not the angle that I need. I need to find the total angle, not this little angle that I have right here. So I'm gonna call that angle of the fourth quadrant, because I'm on the fourth quadrant. Okay, but I need the total angle. I need the total angle. So in order to find that angle, the angle of the quadrant, I'm just going to write this formula. The angle of the quadrant, if you see, I got a trigonometric function between the opposite and the adjacent, that is tangent. So tangent of the angle of the quadrant, I'm just going to use the angle of the quadrant. In this case, it's going to be the quadrant number 4, but this is the general formula. Imagine that I have a vector in the third or in the second or in the first quadrant. So this formula is going to work with any vector that you have in any quadrant. So it's going to be the opposite, that is by over bx. And the formula, in order to find that little angle, equals tangent inverse of by over bx. And that's a formula that we are going to circle. That is going to be the fourth formula that we are going to work with. I'm going to circle the formula, and I'm going to substitute. So in this case, the angle of the fourth quadrant equals tangent inverse of by. By equals minus 7 over 10. Okay, so I'm just going to move over here in order to check minus 7 and 10. Yes, that's correct. And let's do this in your calculators. I got my calculator. I clean the display. So I need to use tangent inverse. Tangent inverse, in order to do that, is going to be shift and tangent. And it's a fraction. I'm going to press this button. This is minus 7 over 10. And then I close the parentheses and hit equal. Okay. And I got minus 34. So that's the value of the angle. Now, before we continue, I'm going to make two notes about this little angle over here. And one note that I'm going to write is that must be positive. Must be positive. And another one is that must be less than 90 degrees. Okay, those are the two notes, very important notes that I need. So the angle of the fourth quadrant equals, it says that it must be positive, so I'm going to make it positive. So it's going to be minus 34. I'm going to make it positive 34.9920. 9920 degrees. Okay. Remember that this angle over here is this little angle over here that I have here, over here, that I have here. I don't want that angle. So I need this total angle that is measured from 0 degrees. So in order to find the total angle, I'm going to draw a little Cartesian plane. I'm going to draw a little Cartesian plane over here. Okay, and imagine that I have a vector over here. I have another vector here. I have another one here and another one here. So each vector, one vector for each quadrant. One, the first, the second, the third, and the fourth. So I'm gonna have this angle of the first quadrant. This is the angle of the second quadrant. This is the angle of the third quadrant, and this is the angle of the fourth quadrant. Okay, and remember that I need the total angle. For example, the total angle for the second vector is this one. So I'm gonna write here the formulas. I'm gonna write it with red. In the second quadrant, the formula to find the total angle will be 180 minus the angle of the second quadrant, this little angle over here. In the third quadrant, the formula will be 180 plus the angle of the third quadrant. Which angle? The angle that I have here, this little angle over here. In the fourth quadrant, the angle equals 360 minus the angle of the fourth quadrant. Which angle? This one over here. And in the first quadrant, the angle equals the angle that I found of the first quadrant. So these are the four formulas that we are going to need in order to find the total angle, depending on in which quadrant we have the vector. So it is very important for you that you have these four formulas. In this case, I'm going to use this one in order to find the total angle, the one that is measured from 0 degrees. So in this case, the total angle will be 360 minus 34.9920. Hit equal. I got a fraction. I press this button 325.008. 325.008. That's the value of the total angle. So the final answer, guys, that I'm going to write is, the final answer will be the velocity vector equals 12.2065 meters per second at 325.008 degrees. And that is the answer of this problem. I hope I made myself clear. Everything depends on where those two guys are. In this case, the rectangular coordinates are in the fourth quadrant, but they could be in the first, in the second, or in the third quadrant. So this was all the procedure that we use in order to find the answer. Very important, we use this formula over here, this formula over here, and depending on the quadrant, we're going to see, we're going to have we need to find the total angle. In this case, the total angle or the vector is in the fourth quadrant, so that's why we use this formula over here. Got it? Well, I hope everything is okay with this problem, guys, and I'll see you in the next video with more physics problems. Bye, guys.